Assalamu alaikum dear students, this is lecture 5. The topic of today's lecture is development requirements. Some of topics of this lecture we already covered in lecture 4. The remaining topic will be covered in lecture 5. This is the agenda for today's lecture. The highlighted topics are already covered in lecture 4. Today we will study how to describe a single use case diagrams, the benefits of basic software development on use cases, scenario. First is how to describe a single use case. There are different sections of it that must be performed in order to describe a single use case in detail. However, the names and steps are essential. If you want to write in a short version of use case, then you can use just name and steps and omit the other section of the use case. First is name. The name should be short, descriptive name to the use case. This should be a verb phrase describing the action the user will do with the system. It's also useful to include a number as a unique identifier for each use case. Second one is actors. List the actor or actors who can perform this use case. For example, in the library system, both a borrower and librarian can check out a book. Third is goal. Explain what the actor or actors are trying to achieve. For example, in the library system, the goal of checking out a book would be to borrow the book in order to read it. Fourth one is preconditions. Describe the state of the system before the use case occurs by listing any conditions that must be true before an actor can initiate this use case. For example, to be able to check out a book, the book must be available and the client must not have any overdue fine. Summary. Summarize what occurs as the actor or actors perform the use case. Related use cases. List use cases that may be generalization, specialization, extension or inclusion of this one. Steps. Describe each step of the use case using a 2-column format, with the left column showing the action taken by the actor and the right column showing the system response. Post conditions. What state is the system in following the completion of this use case? A use case should describe the user interaction with the system, not the computation of the system performed. For example, in a use case of withdrawing money from the ATM, you would describe the fact that the user insert his card, respond to various prompts by pressing some button and then remove his card and money. You would not describe how communication with the bank established and how the system computes any fee at charge. The latter information is also important, but it belongs to different parts of functional requirements. There is example to describe a simplified format use case for opening a file in application. For example, if you want to open a file in MS Word, you should describe a use case for it. Simplified format means that you just write its name and steps and omits the other section of the use case. So its name is open file, and the steps are: first, the actor will show the open command. Choose open command. The system will respond by displaying file open dialog box. The actor will specify the file name and confirm the selection. Then the system will remove the dialog box from the display. Second is briefly describe a use case for living in automatic car parking lot. For example, if you want to exit from automatic car parking, then you have to write a use case for it. A briefly described use case means that you have to write all the conditions, preconditions, summaries, all the sections of the single use case. First is use case name. It can be exit car park by paying cash. It means that its name is to you have to pay cash in order to exit from a car park. Actors are car driver. The goal is to leave the parking lot after having paid the amount due. Preconditions are the driver must have entered the car park with his car and must have picked up a ticket upon entry. Precondition means that when you enter, in order to enter the car park, you must have a ticket issued by that car parking. Summary: when a driver wishes to exit the car park, he must bring his car to the exit barrier and interact with the machine in order to pay the amount due. Related use cases: exit car park by paying using a debit card. Steps: driver will have to drive the car to the exit barrier, activate the sensor. Triggering means activating. Then the system will detect the presence of car, prompt a driver to insert his card. The driver will insert the ticket. System will display the amount due. Actor will insert the money into the slot. System will return any change owing. Prompt the driver to take the change. Raise the barrier. Drive through the barrier and activate a sensor. The system will lower down the barrier again. Use case diagram. Use case diagrams basically are UML notations, unified modeling language notations, for showing up the relationship among the set of use cases and actors. This helps the software engineers to convey a high-level picture of functionality of a system. It's not necessary to create a use case diagram for every system or subsystem. For a small system with just one or two actors, a simplified list of use cases will be sufficient. There are two main symbols used in the use case diagram. One is actor, shown by a stack person. In the use case is shown as the ellipse. Line indicates which actor performs which use case. For example, we can see the 5 use cases: enter a grade for a course, register in a course, find information about the course, add course offering. These are 3 actors. Then the lines show the relationship among these use cases. The use case modeler can use extensions, generalization or inclusion to represent different type of relationship among the use cases. First is extension. Extensions are used to make optional interaction explicit or to handle exceptional cases. A use case extension, for example, what happens if an actor provides the wrong file name to access a given file, or describe the extra interactions that occur if the actor decides to browse in order to locate the required file instead of simply typing a file name. By creating a separate extension use case, the description of the basic use case remains simple. Second one is inclusion. Inclusion allows you to express a part of the use case so that you can capture commonality between several different types of use cases. Even very different use cases can share a sequence of actions. For example, many different use cases might require an actor to specify the password, to browse through a list of items, or to open a file. Rather than repeating the detail of such common interactions in multiple use cases, you can create a special use case that will be included in all other use cases. Such a use case represents the performing of a lower level task with the lower level goal. Third is generalization. Generalization works the same way as in the class diagram and use the same triangle symbol. Several similar use cases can be shown along with the common generalized use case. In example, the general open file use case have two sub-use cases: open file by typing name and open file by browsing. This is the example. Describe the related use cases that have to do with opening a file in applications. Its name is, use case name is open file. Related use cases because it's a generalization of two sub-use cases: open file by typing name, open file by browsing. Steps are: on the left side we have actor action, on the right side we have system response. First, actor will choose open command. The system will respond by a file open dialog box. Actor will specify the file name, confirm selection. The system will remove the dialog from the display. Then it's a sub use case, open file by typing name. It's a sub use case of generalized use case open file. Actor will choose open command. System will display file open dialog box. Actor will select the text field, type the file name, click on open. The system will remove the dialog box from the display. Third one is open file by browsing. Its generalization is open file. Basically, it's a sub use case of generalized use case open file, and it's also included the use case for browsing because we have a separate use case for browsing a file. On left side we have actor action, on right side we have system response. Choose open command, display file open dialog box, browse file. It's a complete use case. We will study these use case separately. Confirm selection and remove the dialog box from the display. Attempt to file that does not exist. It's the extension of file. Open file by typing name. Here we can see if we have type a name that does not exist, then click on open, indicate that the file does not exist. Correct the file name, click open, remove the dialog box. Browse file. If a desired file does not display the directory. Select a directory, repeat step 1 until the desired file is displayed. Select a file. These diagrams show the extension, generalization and inclusions in these use cases. We can already see by these ellipse use cases actors that it shows the extension, it shows the inclusions. The modeling process: choose use cases on which to focus. You should identify all the use cases associated with the software product, but you must varying emphasis on them when developing the system. Often one use case or very small number use cases can be identified as central to the system. For example, in airline reservation system, the centralized use case will be to reserve a seat on the flight. Once identified, the system can be built around the particular use case. There are also other reasons for focusing a particular use case. You may identify some use cases as a high risk because you expect to have problem implementing them. For example, in a GPS-based automobile navigation assistant, you may identify enter navigation mode and speak now as a high risk. These use cases will require exploratory prototype, since it will be challenging to ensure that the voice output is easy to understand and is spoken to the user at the right time. Some use cases will have a high political or commercial value. For example, In an online stock exchange, a use case in which a user can see in real time the evolutions of the value of a given stock would not be essential. The user could do their job without it. Nevertheless, it might be given high priority because of its appeal when presenting the product prototype to potential clients. Use case analysis is a basic way to understand and organize what the system should do, since it's based on user tasks and express the task in natural language. It can help to define the scope of a system, that is what the system must do and does not have to do. Second one is, are often used to plan the development process. The number of identified use cases is a good indicator of the project size. Development progress can be measured in terms of the percentage of use cases that have been completed. The third one is, are used to develop and validate the requirements. Means use cases can also be used for validation of the requirements. If some piece of proposed functionality is not supported by use case, then it can be eliminated. User and customer can also understand the requirements better if they are expressed in terms of use cases. Can perform a base for the definition of test cases. It means that use cases can be used as a base for the development of test cases. Can be used to structure the user manual. Means that use cases can be used to structure for writing of the user manual, because it shows the interaction of the user with the system. However, use cases must not be solution to every problem. There are two things to watch out for. The use cases themselves must be validated using the requirement validation methods. It means that use cases must be validated. If they are not valid, then those use cases should not be included. And use cases should be consistent and unambiguous. There are some aspects of functional requirements that are not covered by the use case analysis. For example, only activities triggered by an actor will appear as a use case. An example of something not shown in the use case, like automatic cleaning of database to remove outdated information. It cannot be shown by the use case, but at the same time it's a very important activity and should be implemented in the systems. Scenario. What is a scenario? It's the instance of the use case. Just like object is an instance of class, scenario is the instance of the use case that express the specific occurrence of the use case with the specific actor operating at the specific time and using specific data. It can help to clarify associated use cases. It's also often simply called a use case instance. For example, describe a concrete use case corresponding to the exact car park paying cash use case. This is a scenario of specific use case. The actor drive the car to the exact barrier. System will detect the presence of car and display please insert your tickets. Insert ticket, display amount is $2.5. Insert $1, display amount is $1.5. Insert $1, display amount is $0.5. Insert $1 into the slot, return $0.5. Display, please check your $0.5 change. Raise the barrier. Driver get the $0.5 and drive to the barrier and activate the sensor. Lower down the barrier. Thanks. It's enough for today.